Alright guys, today we are going to talk about solving a specific type of system. We're going to solve quadratic systems. So remember, quadratic means that it has at least one variable to the second power. Alright, so we're going to start off right with examples. The important thing to remember when you're solving quadratic systems is that you have to solve them algebraically, right? You can't use a graphing calculator to solve these. You can verify to see how many answers you're going to have, but to actually get your answers, you're going to have to solve algebraically. So let's look at our first example. We have y is equal to x squared plus 1, and x minus y is equal to negative 3. So the first thing that I want to do is I want to line these equations up. Like I want to line up the equal signs, right? So I'm going to rewrite them in a neater, more lined up way, okay? So x, there's nothing to line up with, so I'm going to kind of leave a space here, right? And then put my y equals x squared plus 1. Now when I write my second, the x is going to go here where there's a blank space, and my minus y is going to line up with my y term in the first equation. See how that nicely lines up? Then my equal lines up with my equal. I don't have an x squared or an x variable in my my second equation, so I'm going to kind of leave that a space right there, and then I'm going to line up my minus 3 with my constant in my first. So again, all I did was rewrite these two, but I lined them up so that the terms that I could combine lined up together, because now this is one big addition problem, right? I have nothing to add to x, so I just have x, but my y minus y cancels. I bring down my equals, then I have x squared, and then 1 minus 3 becomes negative 2. So now I'm left with x equals x squared minus 2. This is a quadratic, right? I have an x squared, so to solve a quadratic, I have everything set equal to 0. So if I want everything set equal to 0, I need to get rid of this x. To get rid of the x, I'm going to subtract both sides by x. So 0 is now equal to x squared. I can't subtract x from anything, so it just becomes minus x, and then minus 2. Remember, a quadratic is written the squared term first, then the term with a variable that's not squared second, and then the constant number comes last. And now that you have this, you're going to factor it, okay? So we can reverse our box method if we need to. We know that this is supposed to be x squared, this is supposed to be negative 2, and the two middle boxes have to add up to negative 1, right? So we know already that this will be an x and this will be an x to make it x squared. So now we think two numbers multiply together to get negative 2 that add up to 1. Okay, so I'm thinking negative 2 and positive 1, right? Negative 2, positive 1. Oops, positive 1. Okay, that's a 1. It's a 1. All right, because 1 times negative 2 is negative 2, but negative 2 plus 1 becomes negative 1, right? So our two factors that are equal to 0 is x minus 2 and x plus 1. And remember, when you have two factors that equal to 0, that means that x minus 2 is 0, or x plus 1 is 0, which means that x is 2, or x is equal to negative 1. Okay, so that tells us something. That tells us two x values, right? Before, when we solved the system, we took our x value and we plugged it back into our original equation to get the y. Well, now we have to do that twice. We have to do it for this x value and then this x value. So let's do this x value first, x equals 2. Let's go ahead and just choose the first equation. You can choose either one. It's going to give you the same answer. So y is equal to x squared, but remember x is 2 in this case, so 2 squared plus 1. So y is equal to 2 squared is 4 plus 1 is 5. So here's this answer. I got 2 comma 5. right? Now we do x equals negative 1. So y is equal to negative 1 squared plus 1. Negative 1 squared is positive 1, and 1 plus 1 is 2. So this ordered pair becomes negative 1, comma, 2, this answer. So you get two answers, okay? And if you looked at the graph, you would notice that this is a quadratic and this is a linear, and so they're intersecting at two spots, so you should have two answers. So your answer should be 2, 5, and negative 1, 2. All right, let's look at another example. We are going to look at x squared plus y squared equals 9, and then we have x plus y squared equals 7. Okay, so notice how everything's already lined up. That's fine. I notice that I have y squared and y squared, right? If I add them all right now, y squared plus y squared is 2y squared. That doesn't really work for me. So what I want to do is I want to multiply one of these equations by negative 1, so that way it'll cancel, right? So I'm going to pick the second one. I'm going to multiply the second equation by negative 1. Okay, so now I have a new system. I have x squared plus y squared equals 9. Negative 1 times x is negative x. Negative 1 times y squared is negative y squared. Negative 1 times 7 is negative 7. So now I treat that like a big addition problem. X squared cannot combine with negative x, so x squared is just going to come down. Negative x cannot combine with anything, so that's just going to be there. Y squared minus y squared cancels. Now I have my equals. 9 minus 7 becomes 2. All right, so again, we have a quadratic. We want to set it to equal. Well, we wanted to set it to 0, so we're going to subtract 2 from both sides. So x squared minus x minus 2 is equal to 0. So we are looking for two numbers that multiply to negative 2 and add up to negative 1, right? We know that this will be x and this will be x. So factors of negative 2, it's either 1 and 2 or 2 and 1. So let's think, if we do negative 2, positive 1, that should add up to negative 1, right? All right, so there we go. So we have our two factors. We have x minus 2, x plus 1 equals 0. So x minus 2 equals 0, or x minus 1 is equal to 0. So x is equal to 2, or x is equal to negative 1. So now comes the part where we figure out what y is. So again, we're going to plug in x into one of our original equations. It can be either one, and then we solve for y. We're going to do it twice. We're going to do it for this x and for this x. So let's do it for the first x equals 2. So x squared, so 2 squared, plus y squared equals 9. Okay, so we have 4 plus y squared equals 9. Subtract 4 from both sides. So y squared is equal to 5. All right. We have to square root both sides. So y is equal to plus or minus 5. Remember, when you take the square root, you get the plus or the minus. So we end up with two answers. We end up with 2 comma positive square root of 5 and 2 comma negative square root of 5. Okay, we get two answers just from that one x. Now let's check x equals negative 1. So we have negative 1 squared plus y squared equals 9. So 1 plus y squared equals 9. So subtract 1 from both sides. So y squared equals 8. Take the square roots of both sides. So y is equal to, oh, I'm sorry, this needs a square root symbol. So y is equal to plus or minus the square root of 8. Again, when we square root both sides, we had to do plus or minus. So we get two answers for this x. We get -1 positive square root of 8, and then we get -1 negative square root of 8, right? So we got 4 answers. We got 4 answers. So our 4 answers, we get 2 square root of 5, 2 negative square root of 5, -1 square root of 8, -1 negative square root of 8, right? So those are our 4 answers. All right. One more example. In this example, we have 3x squared minus 5y squared equals 4. And then we have x squared plus y squared equals 4. Okay, so this is where you decide, what do we want to cancel? So y squared to the x squared, our choice, right? Let's cancel the y squared because this is a negative and this is a positive. So all I have to do is multiply the second equation by 5, right? So that's what we're going to do. Multiply the second equation by 5, and that gives us a brand new system, right? Our first equation doesn't have to change. Okay, but our second equation is going to change. So 5 times x squared is 5x squared. 5 times y squared is 5y squared. 5 times 4 is 20. Now treat that like a big addition problem. 3x squared plus 5x squared is 8x squared. The -5y and 5y squared cancel. 4 plus 20 is 24. All right, now we're going to divide both sides by 8. Ooh, there we go. And x squared becomes 24 divided by 8 is 3. Now we square root both sides. So x becomes, remember when we square root both sides, it becomes plus or minus. Plus or minus square root of 3. All right, from here, we have 2 answers for x, all right, which means that when we plug into our original equation, we're going to do it twice. First, we're going to do it with positive square root of 3, and then we're going to do it with negative square root of 3. So let's do positive square root of 3 first, okay? So 3 times the square root of 3 squared minus 5y squared equals 4. Okay, square root of 3 squared is 3. So 9 minus 5y squared equals 4. I'm going to subtract 9 from both sides. So negative 5y squared is equal to 4 minus 9 is negative 5. I'm going to divide both sides by negative 5. So y squared is equal to 1, right? Now I square root both sides. But remember, when I square root both sides, I get plus or minus 1, right? However, square root of 1 is 1, so plus or minus 1 is our y, okay? So again, when we let x be the square root of 3, we got 2 answers. We got, when x was the square root of 3, we got positive 1. And then when we let x be the square root of 3, we also got negative 1. That's 2 answers so far. Now we have to let x be negative square root of 3. So 3 times the negative square root of 3 squared minus 5y squared equals 4. Well, negative square root of 3 squared still ends up being 3. So if you notice, this and this are the same exact thing. So when we solve, we should still end up with y is equal to plus or minus 1. So when we let x be negative square root of 3, we end up with plus 1, or positive 1. And then when we let x be negative square root of 3, we also end up with negative 1. So negative square root of 3, negative 1. So again, we got 4 answers. All right, those are all the examples I have to give for y'all. So yes, you don't have to do any additional problems for homework tonight. However, I would like you, to take really good notes on these examples and be ready to do problems tomorrow. Thank you.